In this video, we are going to see how we can calculate the lift and drag on a 3D airfoil. And we can also see how we can set up a simulation that is similar to what is being shown on the screen in Airflow. Well, let's not waste any more time and let's jump right in. All right, here we have Airflow set up on our computer. Airflow is a 3D simulation CFD app that you can download on your Mac. So please check it out, airflowsim.com, and I'll talk more about it in the end of the video. But right now, to start the simulation, we need to import the 3D model. And in my case, that will be this test wing. Hit open. And in my case, the units that I've designed this wing are in centimeters. So I hit centimeters. And there we go. Our wing is pulled in to the software. So once your model is imported, you hit domain. So once you hit domain, we need to set up the domain in such a way that we can get all the readings from different angles, and we are not putting the walls, the boundaries too close to the model. So let's go ahead and set that up. In my case, I want this front plane to be closer, and I want the back plane behind the wing to be farther. So I do that, and the sides look okay. I'm fine with the sides, and the top and the bottom are way too close to the wing. So let me change the top to 0.5. Okay, that looks good. So once your domain is set up and you are happy with your domain, we will move on to boundary conditions. So hit boundary conditions, and that should show you a green arrow which is pointing in the direction of the flow. In our case, the flow is in proper direction, but if you do not have this in proper direction, you can go to the browser settings on the side, hit on boundary conditions, inlet, and then you can change the direction based on how your model is set up. In my case, positive X works completely fine. And then there is also velocity, wind velocity. In my case, 10 meters per second is totally fine with me. So I will move on to the next step, which is meshing. So once you're done with the boundary conditions, hit mesh, and then hit generate mesh. And the three options that we have here are simply saying how quality mesh do you want. Do you want your results to be lower quality, which is draft, and then you have medium quality, which is standard, and then you have higher quality, which is fine. In my case, standard is perfectly okay with me. I just want to calculate lift and drag, and I also want to see the airflow around the wing. But if you want more finer details of a complex model, you can go with the fine setting. This will take a little bit time because it's more finer cells. But in my case, standard is completely fine. In most cases, standard should be completely fine. So let's hit generate mesh. And once the mesh is generated, you go ahead and go to solve menu, and we have 300 iterations right there. I think that is totally fine for the setup we have. But if you think your model is complex and you want more iterations, please increase the number of iterations. And that's totally based on what you are designing and what your model is. And then once you are set up, you can go ahead and hit solve. And once the solve is complete, your results page here, your results button will activate, which you can hit on it, and then you'll have your results instantly. So right now we have velocity as a scalar field. So we can see how the velocity is changing over the wing. And we have a velocity color-coded bar here, which shows the different colors have different velocities that are listed. So we can see that the red is maximum here, and we can see it's a lighter green, and it's got darker green, which is about half the velocity. But yeah, that's velocity, and you got multiple planes. You can view that in different angles and planes. You can also change the position. You can move this plane with this position thing. And you also have an option to select pressure and see how is the pressure acting on this wing at 10 meters per second. So right now we can see that the pressure is higher at the bottom, and then there is lower pressure in the top, which produces the lift. And now for coming to the lift and drag, we have force data right here. So for our wing, we know lift is in the Y direction based on this 3D axis that we have here. So it's Y, and if I go to Fy, so these Fx, Fy, and Fz are total forces which are calculated based on the forces on both the directions, positive and negative axis, and then they're combined to give the overall total force. So Fy is 50 newtons, which is lift for us, which is great. 50 newtons, I think it's about 5 kilograms. Might be wrong, but I always use Google for this. But yeah, we have 50 newtons of force, lift, and we have 11 newtons Fx. If you can see in this, X is, you can hit table and you have positive X, negative X. So positive X is behind the wing flowing this direction, and then negative X is flowing towards the front of the wing. So it calculated both of them, took the 0.5 newtons away from 12 newtons, and that gives us 11.6 newtons. And then the Y is, positive Y is up and negative Y is down. So that is 815 is taken from 51 is subtracted from 51 newtons, and that's where we get 50 newtons right there. And then the Z is the side forces, and they're not much, they usually cancel out each other. But that's how you can get lift and drag. And if you want to see the simulation of air flowing over the wing, all you have to do is hit flow here, and then it generates a flow with 10 meters per second. And you have multiple orientations that you can check the wind flow. And here we are checking the top view of the wing and how the flow is flowing around the wing. And if you want the cross-sectional view to see if there is a break of the flow and how our vertices, if you can clearly see, if you let the flow run for a little bit, you can see there's the vertices, the tip vertices that formed on the wing, and they're traveling backwards. And if you want to see the cross-sectional flow, you can clearly see there might be a separation right there because of the angle of attack of the wing, because I believe I gave 10 degrees as angle of attack. The wing is tilted 10 degrees, and we have this angle of attack. It's tilted 10 degrees, and yeah, so there's the flow, and you can rotate it and see from different angles. And you can also change the velocity. Oh, I apologize. The velocity is 2 meters per second. Let's set it for 10 meters per second on the wing. There's a lot of turbulence right there. The wind is definitely not laminar like it's on the top and the bottom. It's extremely violent right there, and which we know because we gave a 10-degree angle of attack, and that's expected. And let's see how 10 meters per second would act here. Yeah, that's pretty violent wind flow. But yeah, so that's how we set up a 3D airfoil in Airflow, and we can calculate lift, drag extremely easy, and we can also see the flow of air on the airfoil itself. And if you're interested in getting this software, all you have to do is go to airflowsim.com, and this is the website where you can download the software. There's a couple more simulations that's been done here on a few cars and the wings. But yeah, you can go ahead and sign up. We are going to launch soon in 2 days. And yes, if you this tool is a native macOS tool, so you don't have to pay for any compute hours. You don't have to pay subscriptions monthly. You download this software and you can use it right off the box, and you can use it forever. Basically, you can have it on your Mac and you can use it forever. But right now, if you're wanting the software, go into this website, get early access. Put in your email, get early access. The seats are running out crazy, so I would recommend you guys to jump in and take this opportunity. And we are planning to launch it with a good discount for founding users, for first 200 founding users. So I would encourage you all to jump in, go get that early access, get your seat in first 200 so you can access this for a pretty good discount. Well, that is it for today, guys. Thank you so much for watching. I hope you liked the video. I hope you will love this tool and it'll be useful for you in everything that you're doing. We try to keep this tool simple and extremely user-friendly. So yeah, please follow us for more videos like this. And if you like this video, like, and if you have any more questions, comment below. All right, see ya.